Welcome to this explainer on the Model Context Protocol, the universal connector that is completely transforming isolated AI models into highly capable agents. Okay, let's jump right into this. Look, if you've been following the incredibly rapid evolution of modern AI, you know we're moving way past those simple chat interfaces where the AI just talks to us. We are heading straight into the era of agentic AI, where the AI actually does things for us. But to actually do things, an AI needs to be able to talk to the real world, and that is exactly what we're exploring today. We're going to see how this totally new standard is fundamentally changing the way AI interacts with our data, our files, and our tools, literally paving the way for true autonomous agents.
So, imagine you've built this brilliant AI assistant. I mean, it's incredibly smart, it's lightning fast, but right now, it's essentially sitting alone in a completely empty room. How do you actually bridge the gap between that standalone AI and your really essential external systems? I'm talking about your SQL databases, your project management boards in Jira, or your code repositories in GitHub. If you want your AI to actually be useful in a real business context, it absolutely has to have access to all of this. And historically, answering this question has been an absolute headache. It traps developers in this endless cycle of writing custom, super fragile code just to get their AI to read a simple spreadsheet.
Which brings us to the core issue, the AI integration nightmare. To really appreciate the brilliance of the solution we're talking about today, you kind of have to understand the massive pain point developers face when trying to scale AI apps. Just think about the standard systems a modern business runs on: SQL databases, Jira, GitHub, Google Drive, Slack, Salesforce. If you build one AI assistant and want it to read your database, you have to write a custom integration, right? That's totally doable. But then you decide, hey, I want it to read Jira too, so you write another custom integration, then GitHub, then Google Drive. Suddenly, you are writing custom code for every single system. And keep in mind, that is just for one AI assistant. What happens when you start adding multiple AIs? Say, a specialized HR assistant that needs Workday, a product assistant that needs Jira, and a finance assistant that needs QuickBooks?
Well, it quickly builds into a totally unsustainable mathematical problem. We call this the multiplication problem. If your company scales up to just 10 specialized AI applications and you have 20 different data resources or software platforms that they collectively need to talk to, well, you can do the math. 200. That is 200 separate, highly customized integrations you have to build completely from scratch. And honestly, what's worse? It's 200 custom integrations you have to actively manage and keep from breaking every time an API updates or a security token expires or a platform changes its rules. Why are those 200 connections such a nightmare? Because for every single one of them, you're just doing duplicate work. You have to figure out the unique authentication process 200 times. You got to write distinct API calls 200 times, custom error handling, defining the tools, and then dealing with the absolute crushing weight of maintaining all of it. It's this fragile, tangled web of duplicate engineering hours that makes scaling modern agentic AI practically impossible.
So how do we fix it? Enter MCP, the universal language. MCP stands for the Model Context Protocol, and it's the ultimate solution to this whole integration nightmare. Think back to the early days of computers, like right before USB existed. It was incredibly frustrating. You had a different, weirdly shaped proprietary plug for your mouse, your keyboard, your printer, your camera, just absolute hardware chaos. Then, USB came along as a universal standard, and suddenly one single type of cable connected absolutely everything. MCP does the exact same thing, but for AI software. Instead of custom APIs acting like dozens of different messy cables, MCP is literally the universal USB for AI connectivity.
Here is the crucial point. Once a resource, whether it's Slack, a SQL database, or GitHub, exposes an MCP server, any AI application only needs to understand the MCP language to communicate with it. The AI doesn't need to know the specific quirks of the Slack API or the Jira API. Each just speaks MCP. Everything is standardized. This completely eliminates our multiplication problem. Literally overnight, your modern AI agents aren't bottlenecked by integration times anymore. They can instantly plug into a global ecosystem of tools on day one.
All right, let's look under the hood at the three core components. Component number one is the MCP Host. Think of the host as the command center. It is quite simply the main application that you, the human user, actually interact with. So if you're typing a prompt into Claude Desktop or using an AI coding assistant like Cursor or VS Code, or even ChatGPT with MCP support, that application is the host. It sits right at the top of the chain, managing the entire process, taking your input, and eventually giving the final response back to you.
Component number 2 is the MCP Client. You can think of the client as the internal messenger. It lives directly inside that host application. When the AI model decides, hey, I need external information to answer this user's question, it doesn't just reach out to the internet blindly, it talks to the MCP client. The client's sole job is to take that raw intent from the AI, format it into our universal MCP language, and route it to exactly the right place. And finally, component number 3, honestly the most important piece of the puzzle, the MCP Server. The server sits on top of your external systems. It acts as a translator, taking the tools and data from things like GitHub, Google Drive, or SQL, and exposing them into that universal MCP format. And because it's an open standard, any software company or independent developer can build an MCP server for their product. Since the server handles the translation, the AI never has to learn individual APIs again. It just knocks on the MCP server's door and asks for exactly what it needs. Now, as you start working with MCP, you'll run into resources versus tools. Let's clear up a very common beginner confusion right now, so you know exactly what your AI is accessing. An MCP server can expose either resources or tools, and the difference is entirely about reading versus acting. Resources provide read-only information. Think of documents, database tables, files, system logs. The AI just looks at them to gain context. Tools, on the other hand, are all about action and execution. When an AI uses a tool, it is actually doing something out there in the real world, like executing a SQL query, sending a message in Slack, creating a Jira ticket, or committing code. To put it as simply as possible, resources are for knowing and tools are for doing.
Let's put all this together and look at the complete MCP workflow. We're going to walk through a real-world scenario so you can see the host, client, server, and tools interacting in real time. Imagine you type a prompt into your AI asking, what were last month's sales? First, the MCP host receives your query. The AI understands it needs sales data to give you an accurate answer, so it turns to its internal messenger, the MCP client, and asks for the appropriate tool. The client then reaches out to the SQL MCP server. The server executes the actual database query, grabs that sales data, and passes it securely back to the client. Finally, the client hands that raw data back to the AI, and the AI translates it into a nicely formatted conversational explanation for you. Here is the major aha realization of this whole process. Throughout that entire workflow we just described, the AI itself never directly connected to the database. It didn't need the database credentials, it didn't need to know SQL syntax, it had no idea about the database structure. Everything happened completely invisibly and securely through the standardized MCP language. That is the real magic of this protocol. So why does all of this matter so deeply for the future of technology? Well, because MCP essentially solves the absolute biggest bottleneck in modern AI scaling. By replacing that endless web of custom APIs with one elegant standardized protocol and simplifying the architecture into host, client, and server, MCP is rapidly becoming the backbone for AI systems interacting with the real world. We are moving from a world where AI is just a siloed novelty to a world where AI is a deeply integrated active participant in our daily workflows. If you're exploring things like LangChain or building agentic AI, this protocol is the foundation that makes true autonomous workflows possible, without the whole thing collapsing under the weight of maintenance. We've seen how the Model Context Protocol is essentially the universal USB cable for AI. It completely unlocks secure, standard access to the resources and tools that AI actually needs to be useful in a professional environment. So I'll leave you with this. Now that the integration nightmare is finally solved, and your AI can seamlessly connect to the entirety of your real-world business systems, what incredible things are your AI agents going to do next? Thank you so much for joining me for this explainer. Keep building and stay curious.